and this is b, then this is negative a plus b. Same magnitude, different direction. Same magnitude, different direction. Are your sketches kind of like mine? If they're a little wonky, that's all right. I'm gonna have a wonky drawer, but
I didn't sketch it. I just did the answers.
oh, okay. You just did it all in your giant brain.
My giant.
Your big brain.
A big brain.
Big brain. That's it. Mr. Trump's big brain. All right. So, make sense so far? This whole vector subtraction thing.
Yes.
All right. So, would you actually like to use it in a physicsy environment?
Yes. I thought this was a physics environment.
Well, this is practice. Okay, so the river. I've never seen this movie.
That's
but I
a
thought it was
failed
good.
D-Day landing.
Apparently, it's from a movie that I've not seen.
That's the squadron that didn't quite make it.
Yeah. So anyway, the river is a classic vector example. In the river, you've got water traveling in one direction, whoosh, and you want to cross the river. And you basically set your sights across the river, and you go, and then the river moves you as the boat moves you too. So first of all, we start with the one dimension. Imagine a boat traveling at 1.5 meters per second down a river flowing at 1 meter per second. You know the boat's actual velocity to be what? You can do this in your head, right? The actual velocity to be
5 meters per second.
notice the direction of the arrows?
Oh, okay.
2.5.
Yeah. So you know the actual velocity of the boat to be a grand total of 2.5 meters per second. If the boat is moving at 1.5 and the current is moving at 1, then you know the actual velocity of the boat to be 2.5 meters per second.
Yes.
Make sense? One-dimensional vectorization. Now imagine the boat turns 90 degrees. The boat turns and attempts to reach the shore, traveling at 2 meters per second at a 90-degree angle to the flow of the river. Now, what is the boat's velocity? And velocity has two parts. It has magnitude and direction. So, go ahead and figure this out. What is now the boat's velocity? What is its magnitude? What is its direction? You have an answer. Show your neighbor. So, bang in your calculator for a little bit, and you have an answer. Show your neighbor, and see if your neighbor agrees with you.
Which one?
Where I went slow it down and just make it clear to the diagonal. So the vector would kind of come out of it diagonal, which would just feel like it.
I think the x value is just, it's like a graph. So it's like this, so the x value is the y value.
You don't know? Well, I'm here to help you.
With like the math we just did.
Yeah, so make a triangle. Make a right triangle with one leg being the 1 meter per second, the other leg being 2 meters per
I
second.
just don't know which one to start with.
Then to find the hypotenuse.
on the board.
We start with the 1.
You can start with whatever you want.
Whoa.
It doesn't matter.
It doesn't matter. Addition is commutative, so if you add 1 to 2 or 2 to 1, you get the same result.
Okay, it's the square root of what? It's just the
Square root of the x values. Is that y'all is?
So it's the square root of 5, except you just take the square root of it because that's what you then imagine it. Exactly. That's what I said.
Hey Charlie, hey, sometimes
It's how you say it.
it's how you say it.
You know,
Maybe he
I
doesn't
really
understand it
personally
your
do
way.
not think I did that correctly.
Maybe he doesn't. Maybe my way. He just understands it.
So, magnitude of the vector, square root of 5.
Well,
Yes.
Okay,
The
so
square root is 4 plus 1 is 5.
yeah. So again, to find the magnitude of a resultant vector, Rm, is the radical y squared plus x squared. which is 4 plus 1, which is the square root of 5, which is 2.6-ish.
It was 2.23.
Oh, 2.23. Okay, so 2.2. Sorry, 2.2. Cool. So what about the angle? What's its angle?
Oh, now we do inverse. Okay.
I got messed up.
Inverse tangent of y over x. So you can measure this as the interior angle or the overall angle to the origin, as long as you understand what it actually be. Question.
So how do you know that the angle is like?
Would that be a negative?
That's where the drawing comes in. So you have to draw your diagram, basically diagram your vectors, so you know what the calculator is giving you. So I strongly recommend you draw your vectors before you commit to an answer.
I got it.
Okay, you got it? What's the answer, Rome?
Well, I just have a question.
Oh, okay.
Because since the one is going to the left, would it be in quadrant 2?
It would.
Okay.
Okay, question, answer.
26.6.
26 points, so we'll go 27 degrees.
Yeah.
So that is the interior angle, so that is 27 degrees inside the triangle. If you took it to the origin, it's going to be 27 degrees inside the triangle. You also might say that's 27 degrees, since it's relating with the boat, that is 27 degrees west of north. One of. Question or answer?
I got 63.
You got 63?
That was 60.
Okay, so the 63 would be the outside angle down here.
Okay.
Okay. So the 63 would be this angle right there. So it's 27 degrees inside the triangle, or 27 degrees west of north, or 117 degrees, just 117 degrees to the origin.
Isn't it supposed to be?
Oh, because you did 2 over 1. Sorry, yeah, it should be 1 half. Yeah,
Okay. Isn't 2
1 over 2. There you go. Opposite over G. Or G.
And then-
My bad.
Wait, I thought y was 2 though.
Y is actually 2, but the opposite of the angle is.
triangle. Oh.
So again, this is where things get tricky. This is where triangle math gets tricky. Is you need to know what the calculator is telling you. That's why the diagram is a good idea.
Well, yeah, but.
Okay.
My only question was, when we're doing degrees, do you want us rounding to the nearest whole number?
Yeah.
Okay.
There's no reason to have fractions of degrees, unless it's like 1.2 or 6.3. Just use 2 sig figs, and we're gonna be happy.
I used 2 over 1. And
27 degrees or 117 degrees. 27 degrees inside the triangle or 117 degrees to the origin.
Yeah, I used 2 over 1 and I still got that. I just like had to subtract from 180 and stuff like that.
Well, yeah, because you found the angle.
Okay. So, Charles.
How'd you get 117?
I added 90. So I added the 90 because this angle right here is not taken into account yet, so I just added 90 degrees.
It's in 4 quadrants, so you gotta take that.
Does that make sense? Okay.
We can have either or, right?
Yeah. Yeah. And the reason, yeah, you can basically come up with either or. The reason I mentioned all this craziness is if you get an exercise or a test question or a quiz question, it might give you an angle to the origin, or it might give you an angle inside the triangle, or it might give you an angle like a map coordinate. If this is north, this is west, so it's 27 degrees west of north. Does that make sense? What I just said?
Yeah.
So east of north would be that way, north of east, north of west. All right, if you want to move on, give me a thumbs up. If you want to talk about it some more, wave your hand around. All right. The next classic example is the airplane. Airplane. Easy plane, go plane, go. All right, consider a small plane flying into a strong wind. The pilot wants to fly north at 25 meters per second. That's a super, super slow plane, but I just made it this way so the math is easier. It could be 250 meters per second, 25 meters per second. And there is a westward blowing wind at 8 meters per second. In what direction, with what speed should the pilot fly? Try this one. He wants to fly due north. On the map, due north. So how should he point his plane and with what speed should he be flying?
Just a little bit stall.
25 meters per second is pretty slow.
Maybe he's gliding.
I'm not sure.
His engine stalled through there.
Yeah, I'm not sure there is an aircraft that can maintain flight at 25 meters per second. Maybe
Airplane.
the hot air balloon.
That'll work.
You know, you should just replace this with a hot air balloon.
Yeah.
Yeah, how do you have to get a pilot a hot air balloon though? Like,
There's a torch that like
well,
heats
yeah,
up
no,
the air
it heats up
to
the air,
expand it.
make it so
balloon.
like
So it
they
can go up and
flow.
down. How do they go left and right?
Yeah,
Currents
like,
of the air.
I don't know.
because I feel like they're just subject to the wind.
Maybe they have like a. If I was doing it, I would open a vent on the balloon, so that
Yeah,
you open a
yeah.
vent that'll blow it to you this way.
Yeah, that would make sense, but like,
No, what they do is they kind of start off in one spot and then they kind of look at where the wind is going. Like smart
I
people.
feel like they're just
And then
subject
they
to the
just
wind.
kind of
Like if the
predict
wind
that
says
they'll land
screw
there.
you, they're screwed.
Yeah, that's entirely possible. That would be a good Google search. So yeah, Google search that today when you're in Spanish class, and then come back and let me know how they do it.
Well, that's what they always do in the fall, because the winds are predictable.
Yeah.
Yeah, what if we did that as much as possible?
90 degrees.
He would stall. Give her a point now.
One of these times I'm going to wise up and get these things printed properly. Keep getting things printed backwards. One of these days I'm going to fix it.
Whoa.
For the angle?
Yeah.
I'm at 72.
I got 17.
You don't want to wait? What'd you do?
I'm sorry.
You didn't sound it's opposite way over in baseball.
Okay, something.
I think you did the angle.
Goes that way.
It sounded out there.
Oh, so they did time.
Oh, well, yeah, you can do different. You can do
That's the
I did 80. 80 again.
what's for your
I think I'm gonna get big.
Mr. Barge?
Shot the dark. You get right.
I've never actually seen it. I'm familiar with it, but I've never actually seen it.
Seen what?
Yeah.
We have similar size
Yeah,
brains.
I'm not a big Muppets fan. I don't like Muppets and puppets.
But roundabout.
It's not a.
Yeah, it was of course really Muppets.
No, that he's trying to go.
No.
I also have problems with claymation.
Maybe.
Okay, Daryl, do you have a question or the answer?
The answer.
Okay, so Daryl's got an answer. So we got a north vector that we want to go. We want to go 25 meters per second at 90 degrees. We don't want to go anywhere else. But we do have to deal with a westward blowing wind So there is going to be a westward blowing wind, like so, that is 8 meters per second, and at negative,
Oh, yeah.
so it's 180, not negative 180, but 180. Okay. So how should we fly, Daryl?
You should fly 72.3 degrees at 26.35 meters per second.
So we want to fly 73 degrees at how fast?
26.3 meters per second.
26 meters per second. That's right. So in other words, we have to look at the vector and say, all right, this is what we want, and we're going to add vectors head to tail. So there's a couple of different options. We can say want equals plane plus air, or we can say plane equals want minus air. Okay? So in both cases, yep, we're going to do this to get this, and this is going to be the resultant. So plane is want minus air. In other words, plane is want plus the negative of air. Can you see that?
Whoa, whoa, whoa.
So if that's the air, then this is the negative of air.
Oh, that's.
So we can basically say what we want is the plane plus the air. So the plane has to go what we want minus the air. So the plane has to go what we want plus the negative air. Make sense? You can do this?
About it
And again,
like the river.
diagramming helps a lot. I strongly recommend you diagram.
So I did the diagram different, but I got the same answers for both. Would that be okay?
Yeah.
Oh, sure.
Yeah, I didn't mind it too.
Any other questions?
I didn't know
Wait, what's the direction?
All right. Hey, Daryl, while you're up there, can you hit the little button on the back of the camera? The little silver button?
What's the direction?